All of the code we worked with so far in this series ran in a single thread of execution. However, Java allows us to run our code in multiple threads, meaning that code can run at the same time. Though in many contexts, at the same time means one thread is running and then the system switches to another thread, and eventually back to the first one, but this happens so fast that it appears to humans that it is at the same time. While the odds that you will directly manipulate threads in a Java-oriented career is very low, I think it might help to have a basic understanding of how they work. Some of the methods in the object class are related to thread management, such as the wait methods, which will pause the thread in which it was called. To create a new thread explicitly, there are two pathways through which this can be done. One is by extending the thread class. The other is to implement the runnable interface and pass an instance of your runnable class into the constructor of the thread class. Either your extended thread or implemented runnable class should have the run method implemented, which can call any method you deem necessary for your thread. Then you would call the start method on your thread object. The thread object has more methods to manipulate it. The sleep method causes the thread to stop running for that specified amount of time. The join method causes the caller to pause until the target thread completes. Multithreading complicates the programming process considerably, whether in Java or otherwise. In practice, it's more complex and bug-prone than what I have demonstrated here. Unless you are working on a massive project like Tomcat or a framework like Spring, you'll likely never have to deal with multithreading explicitly. If you do end up writing a program that's called by Tomcat or using a framework like Spring, you'll likely be writing code in a multi-threaded environment, but those projects will handle the complexities of multithreading for you.